With the introduction of APIs and other compatible modules for Ansys products in the Python ecosystem, there are new opportunities for developing web apps that incorporate PyMAPDL, which can bring sophisticated simulation insights into the hands of many people. In this lesson, we will start with some high-level planning and a review of the parts that make up the whole web app. Ready? Let's get started. For our web app, the PyMAPDL example model should be realistic, complete, yet be short enough script that we can review it in total. A useful feature of the example will be one that had an analytical solution. This will be helpful when testing the web app inputs range and resulting outputs. One of the first steps is to conceptualize the web app. Any tool easily accessible to all the team members would work. It could be nearly anything, from a hand-drawn sketch to a whiteboard sketch with sticky notes, or an electronic version of the same. Something that you are comfortable with, that allows for changing ideas, arrangements, content, and the like on the fly. Our plan is for the web app to look like this, with the following features: a section that requests model inputs and includes default values, a static picture of the model, preferably with the input shown, a solve button, a section of the model outputs with at least one image and one result listing. If possible, a comparison to the analytical solution. This sketch shows PyDPF working alongside PyMAPDL to produce output. Let's go ahead and scratch PyDPF out and stick to PyMAPDL for the background. It is anticipated that the audience will either be experienced MAPDL users who are interested in web apps or web app developers looking to increase their PyMAPDL knowledge. Possibly you're new to both. With this in mind, let's do a review of the different pieces of our generic web app. We start with Python and Flask. We, of course, are utilizing Python to control the whole process and are implementing Flask for the web framework. In layman's terms, Flask controls what is shown having navigated to a specific web address. It will facilitate retrieving input values to be sent to PyMAPDL and take PyMAPDL output values and send them to be presented on the web page. Next up is PyMAPDL and the three parts that will always need to be addressed. The first part is the MAPDL working directory, where MAPDL keeps files during the solve process. We will need to keep in mind that either an existing folder should be used and cleaned up after use, or a new temporary folder created, then properly deleted after use. The second part is that an instance of MAPDL as a service will need to be launched. Depending on the example model used, there may be options other than working directory that we should set. Lastly, we need to process the input file given the inputs and return the needed outputs. Cascading Style Sheets, or CSS, is a language used to define the presentation of an HTML file in a web browser. A CSS file will be used to define the layout and look and feel of each section, including background colors, font size and color, and text alignment. Hypertext Markup Language, or HTML, essentially defines the content of a web page. For example, the input header section content is, "Please provide inputs." HTML and CSS have some overlapping functionality, but in this example, we will keep it separate. One CSS file can control the layout of multiple web pages. This can be useful when creating a website of multiple similar pages, perhaps a library of PyMAPDL examples. Lastly, for this web application, it will be useful to keep a file of predefined names, paths, and messages. We will end here, and in the next video we will move on to reviewing the supplied files and editing the PyMAPDL script from our chosen example. See you there.